Jai Hind students, welcome to my YouTube channel. Students, knowledge is the best investment as it will pay you the best interest. Again I repeat students, invest in acquiring knowledge as it is knowledge which will give you the best interest. So students, keep acquiring knowledge and it will be eventually beneficial to you and you will definitely be rewarded for that. So with that, let's start this session. In the previous lecture, we have discussed dot product, that is scalar product or inner product, and we have discussed various properties associated with it. In this session, students, we are going to discuss the numericals based on dot or scalar product, right? So let's start with the first question then. First question is, we are supposed to prove that the vectors A vector, which is I cap plus 2j cap plus 3k cap, and B vector is equal to 2i cap minus j cap are perpendicular to each other. Now students, here we are supposed to make use of the fact that whenever the two vectors are perpendicular to each other, that is, if the angle between the two given vectors is 90 degrees, then their dot product is always 0, right? So if A vector dot B vector is equal to 0, then A vector must be perpendicular to B vector. Why? Because A dot B is AB cos theta, and if theta is 90, then cos theta will become 0, so A dot B will be also 0. So in order to prove that A vector, B vector are perpendicular to each other, we need to prove that their dot product is 0, right? So let's prove it. Consider A vector dot B vector. A vector is given to be I cap plus 2j cap plus 3k cap, right? And B vector is given to be 2i cap minus j cap. So we are already aware of the dot product of two rectangular components, right? So here the coefficient of I cap in case of A vector is 1 multiplied by coefficient of I cap in B vector, that is 2, plus coefficient of j cap multiplied by coefficient of j cap in B vector, that is minus 1, plus coefficient of k cap in A vector multiplied by coefficient of k cap in B vector, it is 0. So we get 2 into minus 1 again, minus 2 plus 0. So it will be equal to 0. So we have proved that A vector dot B vector is equal to 0, which eventually proves the fact that these two vectors must be perpendicular to each other. Right students? So this is how this question needs to be done. Okay, let's concentrate on the second question. It's a similar question, very simple one and important one too. Determine the value of n so that the vectors A vector is I cap plus 3j cap plus k cap and B vector I cap plus 5j cap minus nk cap are perpendicular. So it is given that A vector is perpendicular to B vector, which will implies that their dot product must be 0. Right? Let's find its dot product. So A vector is given to be I cap plus 3j cap plus k cap dot B vector is I cap plus 5j cap minus nk cap. It is equal to 0. Right? So the sum of the products of the coefficients of I cap, j cap and k cap, that is how the dot product of two vectors is obtained. So coefficient of I cap is 1 over here. Here the coefficient of I cap is 1. Plus, because I dot I is 1, I dot j, I dot k is 0. Isn't it? We'll make use of the basic results which we have obtained. So here it will be coefficient of j is 3. Over here coefficient of j cap is 5. Plus here coefficient of k is 1. Here the coefficient of k is minus n. So what do you get? 1 plus 15 minus n is equal to 0, or n is equal to 16. So students, the value of n must be 16 for the vectors A vector and B vector to be perpendicular to each other. Clear? Here again we have made use of the very basic fact that in case the two given vectors are perpendicular to each other, then their dot product must be always 0. So students, we are over with question 2 as well. Third question is, we are supposed to determine the magnitude and direction of I cap plus j cap. It's an interesting question actually. So we are supposed to find out the magnitude as well as its direction. So question number 3. I cap plus j cap. So any vector which is represented in terms of I, j, k, its magnitude is given by square of the coefficient of I cap plus square of the coefficient of j cap plus square of the coefficient of k cap, right? So let's find out the magnitude of I cap plus j cap. So its magnitude would be square root of, what is the coefficient of I cap? It is 1. So square of 1 plus, what is the coefficient of j cap? Again 1. So its magnitude is square root of 2. So this is the magnitude of I cap plus j cap, right? Let's draw the diagram. This is suppose x-axis and this is I cap plus j cap. And this angle is to be found, which it makes with, say, x-axis. Now the direction along x-axis is represented by I cap. Am I clear, students? It's represented by I cap. So what to do is, let's consider the dot product of these two. So in order to find the angle between two given vectors, we make use of dot product. So I cap plus j cap dot I cap. This can be considered to be A, this can be considered to be B. A dot B, that's A into B into cosine of the angle between them. So it will be magnitude of I cap plus j cap into magnitude of I cap and cosine of the angle between these two. I cap plus j cap and I cap. The angle between them is theta, which is to be determined. Right? So what do you get? I dot I, it will be equal to 1 plus j dot I, it will be equal to 0. So I'll solve it for you. It will be I cap dot I cap plus j cap dot I cap is equal to the magnitude of I cap plus j cap is root 2. The magnitude of I cap, it is 1 and it is cos theta. So I dot I is 1, j dot I is 0. So it is root 2 cos theta, or cos theta is equal to 1 by root 2, which implies that theta is equal to 45 degree. Cos 45 degree is 1 by root 2, or in radians it is pi by 4. So the magnitude of I cap plus j cap is root 2, and this vector, which is I cap plus j cap, is making an angle of 45 degree with the x-axis. So that's the complete answer, both in terms of magnitude as well as direction, right? So students, we are done with question number 3 as well. Let's proceed further. Question number 4. Question number 4 states that magnitude of a plus b, if it is equal to the magnitude of a minus b, then we are supposed to determine the angle between a vector and b vector. So what is given is a vector plus b vector, magnitude of this is equal to a vector minus b vector, right? So what we do is squaring both the sides, right? Squaring both sides, we get, it can also be written as, if a plus b magnitude is equal to the magnitude of a minus b, then it follows that the square of the magnitude of a plus b would be equal to the square of the magnitude of a minus b. Clear, students? Now, just try to recollect the properties which we have discussed during the theoretical study of dot of the scalar product. We have discussed there that the dot product of a vector with itself will give the square of its magnitude, isn't it? So this is the square of magnitude of a plus b. So from that property, we can write it here as a vector plus b vector dot A vector plus B vector. This is the dot product. So students, which property I have made use of here is the dot product of a vector with itself will give us the square of its magnitude. This is the property I have employed over here, right? Similarly, this can be written as A vector minus B vector dot A vector minus B vector. These are the two equal vectors. The dot product of two equal vectors will give us the square of its magnitude. I think it's perfectly okay. Now let's solve it, right? So A vector dot A vector, simply keep on evaluating A dot B plus B dot A plus B dot B. Clear? It is equal to, let's evaluate this one in the similar manner. So it will be A dot A minus A dot B minus B dot A minus plus B dot B. Clear students? Our objective is to find out the angle between A and B. Let us assume the angle between A and B be theta. Then A dot A, we are aware, the dot product of a vector with itself will give us the square of its magnitude. So it will become A square plus A dot B is equal to B dot A. We are aware that dot product obey commutative law, isn't it? A dot B is equal to B dot A. So these two are equal. So it may be written as twice A vector dot B vector plus B dot B, again it will be B square. The dot product of a vector with itself will give us the square of its magnitude. Over here we get A square. Again, these two are equal. Dot product obey commutative law, isn't it? So B dot A may be written as A dot B. So minus A dot B minus A dot B, it will give us minus twice A dot B plus B square. So A square, B square, B square to get cancelled out, we'll be left with minus 2A dot B can be taken in the left hand side. So what is left is 4A vector dot B vector is equal to 0, which further implies that 4A B cos theta is equal to 0. Now look, theta is considered to be the angle between A vector and B vector. Theta is to be determined, right? That is our objective. Now look, 4 can't be equal to 0, and if A vector and B vector are non-zero vectors, they are non-zero vectors. A vector is not equal to 0 as well as B vector is not equal to 0. So that is, if A vector, B vector are non-null vectors, non-zero vectors, then it implies that cos theta is equal to 0, which implies that theta is equal to 90 degree or pi by 2. So students, if magnitude of A plus B is given to be equal to the magnitude of A minus B, it clearly suggests that the angle between A and B must be 90 degree. That is, A vector and B vector must be perpendicular to each other. Clear? So this was quite an interesting question. Okay, let's proceed to the next question, which will be done in the similar manner. Fifth question is, students, if unit vectors, look, this is cat, carrot or hat, right? This symbolizes unit vector. A vector divided by its magnitude, that is unit vector. It represents the direction of the given vector and its magnitude is always unity. Do remember it. So A cap and B cap are the two unit vectors which are given to be inclined at an angle theta. We are supposed to prove that mod of, that is magnitude of A cap minus B cap, is equal to twice sine theta by 2. Right? Here the angle between A cap and B cap is theta, it's given. So this is to be proved. We are doing fifth question, so this is to be verified. A cap minus B cap is equal to twice sine theta by 2. Right? Now students, what we do is consider, just now we have done A cap minus B cap mod of A cap minus B cap square. right? It will give us a cap minus b cap dot a cap minus b cap. So which property I have used over? The dot product of two equal vectors will give us the square of its magnitude. This is a single vector. These two are equal vectors, so their dot product would be equal to the square of its magnitude. It's clear, students? Okay. Now what to do is a cap minus b cap square. Now let's try to evaluate it, just as was done in the previous question, right? So a cap dot a cap minus a cap dot b cap, this is dot of scalar product, minus b cap dot a cap, minus minus it will become plus b cap dot b cap. Clear, students? Okay, let's evaluate further. Now it can be written as magnitude of a cap, then again magnitude of a cap, and these are equal vectors. Angle between them is 0 degree. Clear, students? Now as I have told you, dot product of a commutative law. So a dot b is equal to b dot a. So it will become twice of a cap dot b cap plus the dot product of these two. Magnitude of b cap, again magnitude of b cap, and the angle between these two. It is 0 degree, both being equal vectors. Right? So what we get is, just let's keep evaluating it. The magnitude of unit vector is 1. We are aware. So its magnitude is 1. 1 cos 0 is 1. So here we are left with 1. Minus twice a cap dot b cap. So magnitude of a cap, magnitude of b cap, and a cap and b cap, they are inclined at an angle theta. It's given. So cosine of the angle between them. So it is cos theta. Plus magnitude of b cap is 1. 1 cos 0 is 1. So it will be 1. So 1 plus 1, we get 2 minus 2. Again, this is the magnitude of unit vector, which is unity, right? This is 1, cos theta. So we'll be left with only 2 minus 2 cos theta. Clear, students? So 2 can be taken as common. So it can be written as 1 minus cos theta. Now look, we need to convert it in terms of sign. That is when we will be able to prove the required statement. So for that, what to do is, let's consider cos 2 theta. It is equal to 1 minus 2 sine square theta. We are aware of this trigonometric formula. Therefore, cos theta, it is equal to 1 minus 2 sine square theta by 2. Let's make use of this formula over here. So what you get is 2, 1 minus, in place of cos theta you can write this 1 minus minus, it will become plus 2 sine square theta by 2. So 1 minus 1 get cancelled, so we are left with 4 sine square theta by 2, and this is a cap minus b cap, the square of its magnitude. Clear? So students, in the last step, let's take square root on both the sides. What we get is, taking square root, we get a cap minus b cap. It will be equal to square root of this. It will be twice sine theta by 2. So this is it. This is what we are supposed to prove. And we have verified the result. Right? So this was a very, very important and good question. So we are over with question 5 as well. Now let's discuss question number 6. Now we have discussed that dot product can be used to determine the angle between any two given vectors, right? So it is a question based on finding the angle between a vector and b vector. So let's proceed with question number 6. We need to find out the angle between a vector and b vector. So let's make use of the concept of dot product. So question number 6. It's given a vector is I cap plus 2j cap minus k cap. So a vector, it is given to be I cap plus 2j cap minus k cap. So what about the magnitude of A vector? It will be equal to square root of coefficient of I is 1 square plus square of the coefficient of j plus square of the coefficient of k. So what we get is 1 plus 4 plus 1, that is root 6. Right? Similarly, B vector, it's given to be minus I cap plus j cap minus 2k cap. So what about its magnitude then? It will be square root of minus 1 square plus 1 square plus coefficient of k is minus 2. So what we get is again 1 plus 1 plus 4, that is root 6. Clear, students? Now let's make use of the concept of dot product. We know that A vector dot B vector is equal to magnitude of A, magnitude of B and cosine of the angle between them. This is to be found. So cos theta can be rewritten as A vector dot B vector divided by magnitude of A into magnitude of B. So this is the master formula which we are supposed to use in order to determine the angle between any two given vectors. A dot B, let's do it directly. A dot B, coefficient of I cap in A vector is 1. Coefficient of I cap in B vector is minus 1. Plus coefficient of j cap is 2 over here and here coefficient of j cap is 1. Plus coefficient of k cap over here is minus 1 and over here it's minus 1. Divided by magnitude of A is root 6, magnitude of B is also root 6. Right? Let's solve it. So we get minus 1 plus 2 and plus 2 divided by 6. Root 6 into root 6 is 6. So 4 minus 1, 3 by 6, that is half. So what we get is, students, cos theta is equal to half. Implies that cos theta is equal to half, which further implies that theta must be equal to 60 degrees. So the angle between these two vectors must be 60 degrees. Cos 60 is half. So by using the concept of dot product, we can easily determine the angle between the two given vectors. Right? So this is how we need to proceed. Okay, we are over with question number 6 as well. Let's go through question number 7 then. Question number 7 is, we are supposed to find out the work done. Work done, as we are aware, students, it's the scalar product of force and displacement. It's an example where we have shown that the dot product of two vectors is a scalar quantity. Work is a scalar quantity, right? So, a particle is displaced from P to Q. So, P is the initial point, 1, minus 3, 2. So, its position vector would be written as 1 I cap minus 3j cap plus 2k cap. Right? And point Q is given to be 2, 1, minus 3. So, its position vector would be written as 2i cap plus j cap minus 3k cap. These are the position vectors. So, I will show it diagrammatically. Suppose this is point P and this is point Q, right? This is the origin. This is R1 vector, this is R2 vector. This is the initial position and this is the final position. So, displacement is drawn by a vector whose tail coincides with the initial position and arrow coincides with the final position. So, this is the displacement vector. So, applying triangle law of vector addition, we get R1 vector plus S vector is equal to R2 vector, isn't it? Apply triangle law of vector addition. These are the two vectors representing the two sides of a triangle taken in the same order. The vector resultant is given by the third side or the closing side of the triangle taken in the opposite order. So, we get S vector is equal to R2 vector minus R1 vector. Okay, students, let's substitute the value of R2 vector and R1 vector over here. So, what we get is S vector, it would be equal to R2 vector, that is 2i cap plus j cap minus 3k cap. minus r1 vector. R1 vector is I cap minus 3j cap plus 2k cap. Let's evaluate it. 2I cap minus I cap, that would be I cap, plus j cap minus plus 3j cap. So that will give us 4j cap, right? Minus 3 cap minus 2k cap. So it will be equal to minus 5k cap. So this is the displacement vector. Now we are aware work done is given by the scalar product of force and displacement. We are aware of it, isn't it? Work is itself a scalar quantity and it is given by the dot product of force and displacement. S is the displacement. So let's substitute the value. Force, the body moves from P to Q under the influence of this force, which is 2I cap plus 3j cap minus k cap dot displacement as obtained is I cap plus 4j cap minus 5k cap. So let's evaluate it. So it will be equal to the sum of the products of the coefficients of I cap plus j cap and k cap, right? So product of the coefficients of I cap of a vector and b vector, here f vector and s vector. So here coefficient is 2, here coefficient I cap is 1, plus coefficient j vector over here is 3 and over here it is 4, plus over here it's minus 1 and here it's minus 5. So what you get is 2 plus 12 minus 1 into minus 5, that will give us plus 5. So we get 19 joule. So students, the work done in displacing the body from P to Q under the influence of this given force is found to be 19 joule, right? So this is how we can determine the work done by using the concept of scalar product or dot product, right? So we are over with question number 7 as well. Now 8th question. This is a very important and interesting question. Actually, I would recommend you to remember this result as well. So the question is, r vector is given and a vector r vector makes an angle alpha, beta and gamma with x, y and z axis respectively. We are supposed to prove that cos square alpha plus cos square beta plus cos square gamma, it is equal to unity, that is 1. So actually, here in this question, cos alpha, cos beta, cos gamma, they are also known as direction cosines, right? Let's first complete this answer, complete this question and then we'll revert back to this. Okay, 8. Now, this is the situation. It's a 3D case. This is the x-axis, this is y-axis and this is z-axis, right? This is z-axis. This is the origin. Now we are aware of I cap, it represents the direction of x-axis. J cap, it's a unit vector, represents the direction along y-axis. K cap, it is a unit vector representing the direction along positive z-axis, right? And a vector r vector is given. Suppose this is point P and this is r vector, it's given. It makes an angle of alpha, beta and gamma with x, y and z axis respectively. Suppose it is making angle alpha with x-axis, beta with y-axis and gamma with z-axis, right? Alpha, beta, gamma are the angles which this r vector is making with x, y and z-axis respectively. We are supposed to prove that. This is to be proved. That is cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is a very important result and this needs to be mathematically proved, right? So what to do is, let us consider the coordinates of P are x, y, z. It's a 3D case. So point P is assumed to be in space having coordinates of x, y and z. So students, r vector can be written in terms of x, y, z in terms of its rectangular components, isn't it? So r vector can be written as xi cap plus yj cap plus zk cap. Fine. Also students, we are aware if a vector in terms of its rectangular components is represented like this, then its magnitude is given by square root of the sum of the squares of the coefficient of I cap, j cap and k cap. So its magnitude, we have derived this earlier, it will be x square plus y square plus z square, or it may be written as r square is equal to x square plus y square plus z square, squaring both the sides. So put this as equation 1, this as equation 2. I hope that now you've understood each and every step, isn't it? Now, it is given this r vector making an angle of alpha with x-axis. Let's consider this. So, if we consider r vector dot I cap, this is I cap, unit vector, represents the direction along x-axis. So, as per the definition, it will be given by r, magnitude of I cap, and cosine of the angle between them. What is the angle between r vector and x-axis? This is alpha. Clear, students? So, substitute the value of r vector over here. R vector is x I cap plus y j cap plus z k cap dot, this is the dot product I cap, and right hand side we get magnitude of r. It can be considered to be r only. I cap, magnitude of any unit vector is always 1. So r cos alpha. Or let's evaluate further. I dot I is 1, so we'll be left with x only. J dot I is 0, k dot I is 0. So in the left hand side we'll be left with only x. So x is equal to r cos alpha. Put this as equation 3. Clear, students? I hope you have understood the concept. Similarly, you need to determine the value of y as well as z. Let's do it. Now consider r vector dot j cap. Consider the dot product of r vector with j cap. So what do you get? Magnitude of r, magnitude of j cap, and the cosine of the angle between them. R vector makes an angle beta with j cap, that is along y direction. So it is beta over here. So substitute the value of r vector over here. It is x I cap plus y j cap plus z k cap dot j cap. Magnitude of r vector is r. Magnitude of j cap, it's a unit vector, it is 1 and cos beta. Now look, students, I dot j is 0, j dot j is 1, so we'll be left with only y. J dot j is 1, k dot j is 0. So in the left hand side we'll be left with only and only y. So y will be equal to r cos beta. Right, students? Similarly, we can prove that z is equal to r cos gamma. Let's prove that as well. Right? So now we'll consider r z equals to r cos gamma. Let's prove that. Okay. Now let's consider r vector dot k cap. So again, as was done in the previous two steps, let's proceed in a similar manner. So as per the property of the dot product a dot b, it's given by a the cosine of the angle between them. So in this case it will be magnitude of r, magnitude of k cap, and cosine of the angle between r vector and k cap. K cap is the direction along z axis. And in the question it's given r vector makes an angle of gamma with z axis. So it is gamma. Substitute the value of r vector. It is x I cap plus y j cap plus z k cap dot k cap is equal to magnitude of r vector is r, magnitude of k cap. These all are unit vectors having magnitude of unity. So we'll be left with r cos gamma. Here, students, I dot k is 0, j dot k is 0, k dot k is 1. So we'll be left with only z. So z is equal to r cos gamma. Put this as equation 5. Clear, students? Now what we need to do is we need to substitute the value of x, y and z from equation 3, 4 and 5 in equation 2 and we should get the result. So substitute the values of x, y and z from equation 3rd, 4th and 5th in equation 2. Let's see what result we are going to obtain. Okay, this is equation 2. So what to do is, let's substitute all the values of x, y and z in this particular equation. So what we get is, this is the equation, students. This is the second equation. Here we are supposed to substitute the value of x, y and z obtained in equation 3, 4 and 5. So what we get is, r square is equal to, x is equal to r cos alpha. So it will be r square cos square alpha. Y we have proved it is equal to r cos beta. So y square would be r square cos square beta. And z we have proved z is equal to r cos gamma. So z square would be r square cos square gamma. So r square is common on both the sides. So we have proved that cos square alpha plus cos square beta plus cos square gamma is equal to 1. So students, this is a very, very important result. Actually, cos alpha, cos beta and cos gamma, these are known as direction cosines. They are known as direction cosines. These are basically the angles which the position vector r vector makes with x-axis, y-axis and z-axis respectively. So let L is equal to cos alpha, N is equal to cos beta and N is equal to cos gamma. Then students, remember, L, M and N are known as direction cosines. Direction cosines may be defined as the cosine of the angle which the position vector makes with x, y and z axis respectively. So if you substitute these values over here, what do you get? L square plus m square plus n square is equal to 1. So this is again a very, very important result, students. Please do remember this conclusion, right? So how will you conclude? The sum of the squares of the direction cosines is always equal to unity, that is 1. Again repeat, students. The sum of the squares of the direction cosines is always equal to 1. So this was a very, very important question. So I hope you have understood the concepts involved in each of these questions, right? So hopefully you will practice more and more such numericals. So that's it for this particular session. Do join me in my next lecture. I'll come up with some new topic and some new interesting concepts, right? Till then, do take care.